f of x, right? What does that mean?
Function of x.
Function of x. Well, yeah, a function f of x, yes? If we see g of x or p of x or q of x, these are all functions. They're functions, but different constructions, yes? So a rational function is our topic today. Hopefully we can get through rational functions in the next 2 days and then hit limits. A rational function is a ratio of two functions. So a fraction made of functions. So example would be if f of x equals p of x over q of x. Yes? This is an entire unit, is doing functions that are not are now fractions. Some rules about this. What do we know about a fraction? The denominator of a fraction. Do we like it when a fraction is 1 over 0?
No.
We just did this in trig. Does not exist. Does not exist. So what this means is q of x, the denominator can never equal 0. That means that we have a domain and range issue. So means the domain of f of x can be shown, and this is going to be 10th grade phrasing. A set. Did you guys start set notation at school?
Nope.
Huh?
No.
No. No. Okay, so then you're gonna learn about this formatting then. But two things, okay? So you're gonna put in brackets, and then x is, the domain of x is, let's translate this, includes all real numbers. This means it includes all real numbers. The R is for real numbers. And also, this bottom part cannot equal 0. That's going to be a little confusing, so I'm going to give you an example. We are going to graph this.
Domain of f
But
can be shown. Shown? Includes all real numbers.
okay. Calculator work. We have 2 new vocabularies for this unit. One is going to be asymptote. Okay? Have we seen asymptote before? Maybe not. Okay. I'm going to show you an asymptote. You may one day see a graph that looks like this. Okay? Notice this graph will go on forever towards infinity, but it will never go below, never below y equals 0. See that? Likewise, this one, the x will go as x goes towards negative infinity, right? Y goes up, but it never, x cannot go, never goes left of x equals 1. See that? So there's an imaginary line. This also has an imaginary line. So asymptotes are imaginary lines or invisible lines that act as a boundary that a line or curve can never pass. Okay, so this is our first vocabulary. Asymptotes are imaginary lines that act as a boundary that a line or curve can never pass. We have two asymptotes on this graph. You will have this is a vertical asymptote. And it is located at x equals 1. And then this one is a horizontal asymptote. Located at y equals 0. I don't like drawing asymptotes, mostly because they're very difficult to draw. You just have to get the line gets closer and closer to 0 or to 1, but it never ever crosses it. That's hard to draw. The second one I like. So we'll talk about the second one soon. Okay. The second thing we're going to see with rational functions. So that's our asymptote. The next big vocabulary word is whole. Right. A spot or point on a line or curve It is represented by an open hole. So a good point about an asymptote is we will see this as a dotted line, and a hole appears as a open circle. If we were looking at a curve, okay, that might be the curve. Would be a hole. Oh, let me do that in red. So the hole would be located at one point of the open circle. It means that at that exact point, that function is broken. Okay, we are going to learn how we use rational functions to show both of these things. For rational functions and for rational functions, we're going to have these two landmark things, asymptotes and holes. They don't necessarily have to have both, but they will appear This has a lot to do with factoring. So we're going to be doing a lot of factoring today. You guys both did pretty well on the factoring pre-assessment, so I'm looking forward to this. If you have enough time to want things that I don't sing that never let go. Ba ba. And if you have enough time, babe, I don't know what you don't know. Okay, we ready? You are the only girl I've ever loved. So, I'm gonna write up an example. An easy example, a hard example. You will need your calculators. I would like you to graph. We're gonna practice the following. One, evaluating points. Two, locating asymptotes, both vertical and horizontal. And then three, finding holes. My favorite is three, but we must learn all of them. So, the first example, we're gonna go through no holes. So I want you to graph this on your calculator. F of x equals x squared plus 4x minus 13 over x minus 3. I would like you to do two things. Section 1 is find f of 2. Yes? And then B, I want you to do find the asymptotes. You want to answer them as it should be x equals something and y equals something. You will not always have both types of asymptotes, but I'm just writing them out. Y is a horizontal asymptote. X would be the vertical asymptote. So put those in your calculator or your Desmos, and then you're gonna figure that out. That's gonna be your first checkpoint. Jaden, how's it going?